Welcome back. In the last class, we have seen about the modes of operation of MOSFET without inclusion of source and drain terminals. Just we will quickly recap what we had discussed in the last class. Whenever the gate voltage is less than 0, then this mode we are going to call it as accumulation mode. Whenever the gate voltage lies between 0 and the threshold voltage, there is no channel formation but the holes are going to be depleted. That means it will create some space. Okay, and finally whenever the gate voltage is greater than the threshold voltage, then there is a channel inversion. That means a channel formation takes place. That means it is very clear with these three conditions we can come into one conclusion. The gate voltage must be greater than 0. That means the gate voltage must be positive. Now we will see the Nmos working operation by including source and drain terminals along with the gate terminal. Now we are going to discuss about Nmos working operation. Is it clear? Now observe very carefully. This is an Nmos. That means it consists of a p-type substrate and n-type diffusions. Now observe very carefully. When a battery is connected between gate and source terminal, a battery is connected between gate and source terminal in this fashion. That means I can call this as VGS, that means voltage across gate to source terminal. Now if you observe very clearly, whenever a battery is connected between gate to source terminal, then what will happen? Then the positive charge carriers will be comes and stay here. Then it will try to attract these electrons. Okay, then the electrons will start to move upward direction. Is it understood? Now let us consider when this gate source voltage whatever we have applied, okay, it is less than threshold voltage, but don't forget it is positive itself, but it is less than threshold voltage. Is it understood? Now observe when this gate source voltage is less than threshold voltage, what will happen? Then this electrons that doesn't have that much capability to come and stay here. Is it clear? Okay, but it will start to move upward direction, but there is no channel formation. Therefore whenever the gate source voltage is less than threshold voltage, this is known as cut-off region. Okay, what is the region? You are going to call it as cut-off region. Is it understood, all of you? Okay, next we will see the second condition whenever the gate source voltage is greater than the threshold voltage. Is it clear? Now if you observe that whenever the gate source voltage is greater than threshold voltage, what will happen? Now you can observe very carefully. Okay, now they can call this one as second condition. Whenever the gate source voltage is greater than threshold voltage, then this electrons will come upward and it will create a channel here. Okay, in this fashion it will create a channel. Is it understood? Now there is a channel between source and drain terminals. Okay, the important point here is the gate source voltage must be greater than threshold voltage. Now can anybody try to tell what is threshold voltage? Anybody? Absolutely. That means the threshold voltage is the minimum voltage required to enhance the channel. Is it clear? Very importantly, this threshold voltage is known as the minimum voltage required to enhance the channel. Now talk about what about the current in this condition. Whenever the channel is formed, okay, now the major issue is the electron should flow from source to drain in this direction. Therefore we required one more supply, that means one more potential we required. Okay, now if you observe that a battery is connected now between drain and source terminal. If you observe that, once again I am taking a battery here between drain and source terminal. Okay, minus plus this battery I am going to call it as VDS. Now what will happen, guys? Absolutely. There are a positive charge carriers. There are a negative charge carriers. These negative charge carriers will repel these electrons. These positive charge carriers will attract these electrons. Then what will happen? Definitely, absolutely. There is a path from source to drain. Okay, and the electrons flow in this fashion. Therefore, the current will flow in this fashion. In this manner, there is a increasing current in this condition. Is it understood? But the major issue is how much of voltage we have to apply, okay, at drain to source terminal. That is a very important point we have to talk about. Is it understood? Now, very importantly, remember all of you, first of all, after formation of channel, that means after channel is formed, what is the remaining voltage present at this terminal? Anybody from the class? You have applied VGS, okay, you have wasted the threshold voltage, then what is the remaining voltage? Anybody? What is the effective gate voltage? Absolutely, the effective gate voltage is what? VGS minus VT. Is it understood? Absolutely. Is it clear, all of you? That is a very important condition you have to remember. Is it clear? That means the effective gate voltage is what? VGS minus VT. Therefore, what is the voltage you have to applied between drain and source terminal means very important. Don't forget, VGS should be greater than VT, and must and should this drain source voltage must be less than VGS minus VT. I hope that are you clear. Okay, then what will happen means there is a slight bend in your channel. Why? Because this is very important. There is a slight bend in channel because here if you observe that there is a p-type semiconductor and n-type semiconductor. Therefore, there is a p-n junction diode, parasitic p-n junction diode here. Is it clear? If you connected this n-type terminal, okay, to positive battery, positive terminal of battery, then it is which bias? Absolutely. Which bias? Reverse bias. Is it understood? Therefore, the depletion region increases, the channel slightly bends. Is it understood? Okay. Now, if you talk about what will happen here, okay, if you exceed your VDS greater than or equals to VGS minus VT. Is it understood? We will see that condition also. Now, first of all, tell me, whenever VGS is greater than VT and VDS is less than VGS minus VT, the current will increase like this. And this region is known as what? Absolutely. Active region, or somebody will call as non-saturation region, or somebody will call as ohmic region, triode region, linear region, like that. Is it understood? Now we will see the third condition. What will happen? Okay, in the third condition, we will see the third condition. Is it clear? Okay, now observe very carefully. I'm going to change this condition, this third one. VGS must be greater than VT, but VDS is what? VDS, if you observe that VDS is greater than or equals to VGS minus VT, what will happen? Now, further, there is high depletion between the PN junction diode parasitically formed. Then what will happen? Then there is a further bend in the channel. Then the channel is going to be pinched off. I will use different color. The channel is further bent and there is a, okay, pinch off channel. That means the channel is going to be pinched off. Is it clear? That means there is no path further from source to drain. Is it understood? Then whatever the current remains at drain terminal, okay, the same current will be appear. Therefore, the current is what now? Constant current. Is it clear how the current is now? Constant current. Therefore, this region is known as what? Saturation region. Is it clear? These are the three conditions and this is the operation of MOSFET. Okay, we will see the channel, okay, length modulation, that means channel, okay, variation. Okay, observe very carefully. I will show in one other picture. Now observe, when VGS is greater than VT, channel will be like this. Okay, then when VGS is greater than VT, and if you want to observe current, VDS should be present. When VDS is less than VGS minus VT, VGS minus VT. Because of the reverse bias here, what will happen to the channel? See here, the channel will slightly bend like this. Okay, but there is a path full-fledgedly, therefore the current ID will start to increase. Is it understood? This is this condition. Okay, second condition actually. The first condition is what? VGS is less than VT, no channel, therefore no current, therefore you can call it as cutoff. This is cutoff. When VDS is less than VGS minus VT, the current increases and this region is called absolutely. What is the region? Active region. Okay. Now we will see what happens when VDS is further increased. Now observe very carefully. I am going to show some variations in the channel. Okay. Now if you observe clearly here, when VGS is less than VT, there is no channel. We can call this one as what? Cutoff region. Therefore, there is no channel. Is it clear? There is no channel if you observe. Therefore, what is IDS? If somebody asks, IDS is what? 0. Now, in the second condition, when VGS is greater than VT and okay, VDS is less than VGS minus VT. Is it clear? There is a channel, but observe that previously when VGS is greater than VT, the channel is like this full-fledgedly. Now when VDS comes into picture, it will slightly bend. Is it clear? Because of the reverse bias present in the PN junction diode. Okay. Now if you observe the third condition here, that means when VGS is greater than VT and VDS is what? Greater than or equals to VGS minus VT. What is happening here? There is further increase in the reverse bias here. The channel is going to be, okay, bend in this fashion. Okay, and there is a pinched off. That means the channel is going to be pinch off. Is it understood? Okay, here that means if you observe that there is no further flow of current here, the channel is pinched off. The voltage at which channel is pinched off, that voltage is known as pinched off voltage. What is the minimum voltage, okay, where the channel is going to be pinched off? If you observe this condition, VDS is greater than or equals to, that means this equal to condition is the minimum voltage where the channel is going to be pinched off. Is it understood? Therefore further there is no increase in current, there is a constant current here. Therefore this region is going to be called as what? Saturation region. Is it understood? Saturation region, that means a constant current source region. Okay, whenever VGS is greater than VT and it is less than VGS minus VT, what is the region? Active region. Is it clear? Then finally we will conclude this Nmos working operation by writing the conditions along with its equation. Okay, now if you observe that, I am going to write the condition. Condition number 1, when the gate to source voltage is less than threshold voltage, is there any channel? Absolutely no channel is there. Is it understood? That means, is there any current? No current is there. Is it all of you understood? Is it understood? Then what is the region here? Absolutely. What is this region? Cutoff region. Okay. Now coming to the second condition. Okay. The second condition. Now we should maintain the gate to source voltage greater than the threshold voltage, but don't forget, and drain source voltage must be less than the effective gate voltage. What is the effective gate voltage? VGS minus VT. You can call this one as what? Effective gate voltage. Okay, now here we will see what are the bullet points. What first one is there? Channel is there. Absolutely, there is a channel. Second one is there what? Okay, increase in current. What is that? Increase in drain to source current. And finally, what is the region? Absolutely, what is the region you are having? Active region. Is it clear? And the last condition, if you observe that, the third condition, in this condition VGS must be greater than VT itself, and don't forget, if VDS is greater than or else equals to the effective gate voltage, okay, equals to the effective gate voltage, what will happen? Is there any channel? Yeah, absolutely, there is a channel. Is it clear? Now is there any increase in current? No, there is a pinched off channel is there. Pinched off channel, the channel is pinched off, therefore constant current is there. What current is there? Constant IDS is there. Since it is constant, therefore we can call this region as what region? Saturation region. Absolutely guys, saturation region. Is it understood, all of you? Yeah, if you are having any doubts, you may ask. Thank you very much for each and everyone. Have a nice day.